like to thank Derive and NJHA for putting this together, and for those of you that have signed up to come in to learn about the electroclave and disinfection mobility strategies that SealShield has put together and designed for multiple health systems starting last year, going into 2018 now. Can't believe it's already 2018. So with that and introductions, I'll go ahead and get started. So quick backdrop, for those of you that are familiar or not familiar with SealShield, we are an infection control company. We started a little over 10 years ago, and most of our products, our core products, are found today in about 65% of most U.S. hospitals. Our focus is specifically preventing infections with the mission of saving lives, and we started that mission with the first technology development of the world's first ever washable, dishwasher safe, antimicrobial keyboard and mouse. Since then, that was 10 years ago, we've progressed as a company. I would say we're far more technologically advanced today, beyond just what most people know us for, which is our keyboards and mice. And we have worked with several health systems over the last, it's 4 years now, in understanding some of the real problems that health systems are faced with today. So one of the key things that we are finding as we work with our advisory council, which is a group within SealShield made up of both clinicians and professionals from the information technology side across multiple health systems from the East Coast to the West Coast, we get together once or twice a year and we listen to their problems, and we look and see what technologies that are available to us and what we're developing, and to pair those up, ideally to help them solve their problems. So going back 4 years ago, the common theme that we heard from this group was all around mobility. Mobility was growing in numbers rapidly. I think 4 years ago, some of my institutions on the advisory council only had a few hundred mobile devices, at least corporate-owned devices that were floating around their institutions. Those very same institutions today, one of which has got over 15,000 mobile devices moving around. So they were very accurate in predicting a problem that was coming and growing exponentially. So we sat down with them and listened to the problems at the time where mobility in numbers wasn't as strong, to see exactly what they were faced with. So these 5 points that I'm sharing with you now, again, these 5 points didn't come from within SealShield. The electroclave product that we're talking about today was truly developed in partnership with about 3 health systems across the US. And really, we pulled the requirements of this build, this product build, directly from the problems that they were faced with. So I'll go ahead and kind of briefly go into these 5, and then as we progress through the presentation, we'll see how the application and the solution that we have developed actually truly answers these. So the first things first, infection control obviously was a big concern for all the health systems in our advisory council. The common theme that we heard was, hey, we've got no disinfection standardization and we have 0 compliance auditing. And what we mean by no disinfection standardization is some of the health systems said, hey, well, we checked with Vocera, we checked with Apple, we checked with Samsung, whatever portable electronics that they were concerned about at the time. And we've gotten our quote unquote cleaning protocols, acceptable cleaning protocols, not disinfection. And I'm going to speak about that later in the presentation. There is a clear distinction between cleaning and disinfection. It's commonly mistaken, those 2 words and those 2 processes for each other. So, you know, a lot of these manufacturers, Vocera and Apple, they were not giving disinfection processes and standards for how to clean the devices that you're using. They were giving just cleaning processes. So they said, in one case, the best we have is we can wipe the device with a 70% IPL wipe. And that's as close as we're going to get to disinfection. And if any of you on the phone are clinicians, as you well know, a 70% IPA is not going to get you any closer to disinfection than merely maybe even wiping the device with a microfiber cloth. So truly what we saw and what all the health systems were coming back to saying is like, we don't have any way to standardize disinfection. We've got some quasi approaches to cleaning, but no disinfection. Furthermore, even let's assume that there was a perfectly compatible disinfectant wipe, chemical wipe that you could do a chemical disinfection with on those electronic devices that was broad spectrum. There was no way for these health systems to be able to have any type of compliance auditing on whether or not that wiping process ever took place. So if you were trying to achieve disinfection from a chemical standpoint, even still, there was a big gap, and this was pointed out by Kaiser and our work with them out in the Irvine campus is, hey, okay, so we have a disinfection chemical that we can use in this area of the hospital because we've got a concern for C. diff here, so this is going to be a bleach wipe, and we've got a concern for this bug in this department, so this is going to be a different cavi wipe. And that they tried to look at the compatibility of the bleach or the cavi wipes, and 9 times out of 10, there was no compatibility with those wipes to the electronics. But they said even in an ideal world, even if we had the compatibility to clean the electronics that way, we'd have no idea if it was getting done. Who did it? When did they do it? And how well did they do it? So compliance auditing is still a big issue in infection control around portable electronics. The second piece around portable electronics, again, as I told you, the advisory council within our company is really a mix between professionals from the director C-suite level all the way down to managerial level, information technology side, as well as the clinician side. And, you know, a lot of the stakeholders in the meeting that come from the information technology side truly harped on the fact that we have no idea how to control our asset allocation when it comes to portable electronics. We do a horrible job just with infusion pumps, much less 200 growing to 15,000 tablets flowing around our facilities. So, you know, there was a big issue, IT for a given department. They were given workflows, or they tried to understand workflow studies from departments on how they were going to use these corporate-owned devices to provide better patient care and patient outcomes. And, you know, it was a real guesswork on how many devices do we really need in this environment. Are we sharing the devices? So does that mean that the devices are pooled and we're going to buy 30 for a department, and you know, we've got 15 people on any given shift rotation? Or are we doing a one-to-one? Are we assigning these devices physically to the end users? A lot of guesswork initially going back 4 years ago, and we've made a lot of strides forward and helping them with asset allocation now, but it was a big, big problem. They didn't know if they were over or under purchasing, and depend upon who that budget fell under. So maybe if you're a department in your healthcare system that is responsible for the budget of those corporate-owned devices, you know, that's something that you want to be sure that you've got just enough devices to make sure that you're not sacrificing patient care or putting inefficiencies in your workflows, your mobility workflows, and certainly making sure that because of the limitation of purchasing, that you're not providing the best patient outcomes as possible. The whole reason we moved to mobility was to assist us to create efficiencies. We certainly don't want to be on the opposite end of the spectrum of it, creating more inefficiencies. So asset allocation is a big problem. Inventory control, another piece that was brought up by the advisory council. And again, this was really driven more so from the information technology side. There were some inputs from department managers like OR managers and directors, especially when they own that asset. They had no way when they did a shared asset workflow to determine who had what, when, and where. And so asset security became a big issue. One of our facilities, to give you a prime example, and it may not be as severe with you, again, it's always different institution to institution, but they lost close to 600 mobile phones on their mobile heartbeat platform in 1 year. That is a massive loss. And the reason being wasn't because they didn't have mobile device management software in place. It didn't mean that they didn't have security software, geofences in place. It was the sheer fact that when you've got shared devices in a department, people are moving all over the hospital. And at any given time, if that person's not logged into that device, all of the mobile device management softwares can't tell you who has what. And they certainly can't tell you where they picked it up from and where it's going. So that inventory control piece was certainly still problematic from a security, asset security. The other side of the fence from inventory control was this idea that these devices, they must be charged. And how are we charging them efficiently? And the difference between smart charging and just general charging through USB or through an enterprise charging station is very, very different. And so what they found is, let's say they picked the perfect number of devices to fulfill a workflow in a department. Let's say it was 30 phones that were running mobile heartbeat in the ICU department and floor, and 30 devices was the ideal number. But 6 months in, because the battery life of these devices improper charging, that no longer was 30 the perfect number. Now you've got devices that aren't making it through an entire shift. Therefore, they've had to increase their purchasing allotment and allocation for that department to keep the workflow perfect. So even battery charging and battery maintenance long-term, especially with some of these portable electronics that don't have hot swappable batteries, is something that is very important. All right, so moving along on the clinical oversight, this piece, so I can get off this slide and keep moving here, it was probably the most significant worry that we got from the advisory council. And then you can imagine it came from the clinicians and the epidemiologists and the council. And the fact is they're very, very worried because of the research that's come out around these portable electronics and how significant that they have been determined to be the greatest cross-contamination point in your entire facility. They have no oversight of which portable electronics are engaging with which patients through which staff at any given moment. And that presents a very, very big risk, because if we have a patient that comes in and we don't find out till 24 hours later that that patient actually does have some infectious disease, then 24 hours later, that patient's record gets updated with a contact notice. But at that point, leading up to that, which electronics and which devices interacted with that patient that then maybe potentially moved to the next patient room or to the next staff member or the next floor. That visibility, there was zero visibility. That was a major concern for the clinicians on the board. So, getting their arms wrapped around how are we going to be able to see where these are moving, when they were disinfected, when they were cleaned, was a very big portion of the requirements that drove the electroclave. So I touched on mobile device, MDM applications, just an acronym that is oftenly referred to as mobile device management. The thing with mobile device management, we weren't in the market to replace mobile device management applications. So you at your facility may use things like AirWatch or Mass 360. There are several of them out today, and they are very much needed, but they are very misleading. So the mobile device management applications really only help you manage the device and everything within the device. They have no capability of managing all your physical behavior. So there's no physical behavior insight. So again, this is not a substitution for a mobile device management application. It is absolutely a complement, and it is in such a way that one does not replace the other. You must have both to truly do proper mobile device management. So I'll move along. Obviously, from those 5 requirements, these are the questions, both from the infection control side of the house as well as the IT side, that the organizations must be asking themselves. How are we going to manage disinfection for our mobile devices or portable electronics? Who's going to enforce these procedures that we put in place? How are the procedures going to be audited? And are the disinfection procedures in place always validated? Right? So we have this idea of compliance and auditing, but the opposite side of that is validation, which is equally as important. IT questions, of course, how are we securely storing our devices in the organization, especially if they're in shared pooled workflows to where devices aren't handed out or assigned on a one-to-one basis. How do we get full user device accountability? How are we going to charge these corporate devices? And how do we automate asset allocation? So moving along with those questions and things and problems, some of those problems may resonate with you and your institution, things that you may be already discussing today or have been discussing in the past. But let me go ahead and shift gears here for a moment, and let's talk about a little bit of the research around portable electronics and mobile electronics. So one of the first studies that and there's multiple, you'll hear me reference many of them throughout the presentation. But one of the first studies that we truly looked at that we felt had a major impact to healthcare organizations and institutions was, you already, and just about every institution in the US is heavily invested in hand hygiene. And the debate becomes, how good is our hand hygiene effectiveness when we are in an environment where we're using and we have multiple mobile devices or portable electronics that don't have as much investment or as much process around the disinfection of those particular assets. So in this study, what was done is they took a mobile phone and they looked at a staff member's hand after a disinfection. So a true hand hygiene process with the staff member's hands, and this was multiple staff members within the study. And long story short, what they found was that the bacterial contamination that was found on the mobile phone would mirror the staff member's hand after they've already been through hand hygiene. So they would go through, they would have them disinfect their hands and their hygiene and their disinfection hand hygiene process. They would run a baseline sample of the hand and go, okay, no pathogens and no bioburden found on the staff member's hands. They would ask them to touch their phone one time. This is a key part of the research. One interaction with their phone. They then remeasured their hands to get a secondary baseline. And lo and behold, the bacterial contamination on the phone mirrored the hands instantaneously to the same level of CFU threshold. So the 93.7% bacterial contamination threshold on the phone mirrored that onto the clean hands after the clean hands interacted with the phone one time. So what this tells us is that while we may think that we have hand hygiene effectiveness of, the standard that the CDC quotes of effectiveness in the marketplace is around 22%. If we think that we have 22%, the next question we should ask ourselves are mobile devices within our process? And if they're not accounted for, I can assure you with this research, and there's about 6 other peer review papers that have been done with the same very abstract background, that hand hygiene essentially is canceled by dirty mobile devices that are not properly disinfected and managed. So this is a big issue, right? This is something we've already invested in, and we're losing traction on by the implementation of these portable devices. So one more piece of research to look at, and those of you who are familiar with it, this is Dr. Curtis Donsky. He posted this in 2013 in the American Journal of Infection Control. And they looked at all of the transmission vectors within the healthcare system, as you can see in the illustration down here below. And if you note, one of the things that sits almost in the center of this entire workflow process is portable equipment. So that would speak to directly things like mobile devices, your communication devices, whether it be a Vocera badge or an ASCOM phone or a Cisco voice over IP phone, or maybe a Volt, whatever your communication platform is in the hospital, including things all the way up to infusion pumps, et cetera. Portable equipment was the epicenter. So it had the greatest impact to cross-contamination within all of the hospital. And Dr. Curtis Donsky said in this quote that it's plausible that a more comprehensive intervention of these high-touch surfaces and portable equipment would bring the most effective outcomes to preventing hospital-acquired infections and breaking the chain of infections within your institution. So again, we already know that the devices cancel good hand hygiene. We know that we've looked at multiple workflows and cross vectors and transmission rates and maybe which devices or surfaces are contributing. And lo and behold, you find portable equipment in the center. And so this is something of great concern that we must get our hands wrapped around. Moving along, this comes directly out of the CDC. I said earlier in my presentation that I would talk a little bit about cleaning versus disinfecting. And this is where I want to harp on it, right? So The CDC has even put standards out for these portable electronics used in your healthcare institutions and systems today. And via CDC, they expect a ratio for cleaning versus disinfection of enterprise mobile devices to be 5-to-1. What that means is that for every 5 cleaning wipes, so if you provide wipes to your staff, like an IPA or just a plain microfiber cloth wipe, that for every 5 wipes in one day, that there should be 1 high-level disinfection. This is what the CDC says is best practices for you to properly manage the cleaning and disinfection of those assets. So the difference, again, between cleaning and disinfection, again, these terms often get used and substituted for one another. You know, cleaning is strictly only the process by which foreign materials, dirt, grime, dead skin cells, etc., are removed from the surface of an object. So in this case, with portable electronics, if you're using a microfiber cloth or an equivalent cloth to physically wipe the device down to remove the dirt, grime, oil, dead skin, etc., that is just cleaning. That is not disinfection. Cleaning does not replace disinfection, and disinfection does not replace cleaning. So that's something key to remember. You must be doing both. And again, it's a 5-to-1 ratio. So with that research backdrop and a little bit about some of the problems that the other healthcare institutions brought to us from our advisory council, we spent about 2 years in R&D developing the electroclave. And the key for SealShield in this process was not developing a tool, but truly developing a solution. So the electroclave as a whole is a solution that allows you to fully automate your mobility management processes when it comes to disinfection, to charging, to syncing, and to storing your portable electronics within your departments or your entire health system. So we'll get into each of those 4 pieces individually, both at the electroclave physical box level, as well as the software that runs behind the scenes that truly takes this from a tool to a solution. And before I get started there, I do want to make sure to point out one more thing that we want to be clear about. There's several ways to achieve high-level disinfection. And when we were developing the electroclave, we looked at a few of the competitors in the market space that were doing or trying to attempt to do high-level disinfection and the management of that. And the problem we found was that everyone had tools. And what I mean by that is everyone had a device or a widget. They said, here, this is how you can disinfect and clean your mobile devices. The problem with those is those tools were on a platform I like to refer to as buy and hope. That means that you're going to invest in that particular asset, and you should hope that your staff members and the end users actually use it. There was no intelligence behind those other systems, even today, to truly determine is, in fact, that product or that tool being used? Is it being used properly? And if it is not, what are we doing about it? So when we got into this space, we said, okay, we do not need to come to market with a Me Too tool. We need to come to the market with a true solution. So I'll go ahead and talk about what we're doing in disinfection differently than what's being done in the marketplace today and how our other health systems are embracing this. So specifically around disinfection, the electroclave is leveraging and utilizing LED technology. So you may have some UVC robots, maybe even in your health systems already today. So you may be familiar behind that. UVC has phenomenal efficacy, broad spectrum across both viral and bacterial pathogens. And but most of the UVC, I would say actually 99% of the UVC applications in healthcare today are done, and the UVC light is generated with a compact fluorescent bulb that oftentimes contains mercury. When we developed this application, we wanted to keep the product green and safe, so there was absolutely no initial requirement drivers for me to use a compact fluorescent UVC bulb. So we went out and we developed an LED. It's lower energy. It doesn't produce heat. We'll talk about that and why that's a big issue. And obviously it doesn't contain any mercury, and it's very small and compact. So when we looked at UVC and we looked at the disinfection of portable electronics in this platform, we actually didn't start with UVC. We looked at all of the various high-level disinfection capabilities and avenues. So whether we're talking about hydrogen peroxide vapor or peroxones or trioxidanes, there's many different ways to expose portable electronics to something other than a wet chemical for its disinfection. So we put them all into a matrix and we reviewed all of them, and we kind of ended back at UVC. It really, truly was the best application for electronics. But what we found about the electronics is that in order to properly disinfect them with UVC, you've got to eliminate all shadows. So with the limitations of UVC and compact fluorescent bulbs, we found that there was no lighting geometry that you could design to properly disinfect a device 360 degrees, all angles, without causing a shadow. So that was our first problem to solve, and we were able to solve that with our LED technology because of the positioning of the technology in our chambers, because of the compact form of that LED versus, again, the compact fluorescent tube. So in the electroclave, we're able to excite all surfaces of an electronic device with UVC to allow that 4-log efficacy, broad spectrum across both viral and bacterial pathogens, while not adding a degree of temperature rise in the device. And that's very important because, again, in this chamber, in the electroclave, we're not only worried about the disinfection of the device, but remember, we also have to worry about charging the device, and IT's got to worry about syncing and provisioning the device, especially if this is a device that goes between patients. So maybe you use mobility tablets, for instance, for patient experience. Some of our partners today and institutions that have gone live with the electroclave do that. So there is typically a process to where once that device leaves patient A before it goes to patient B, it must be wiped. So if you want to disinfect this device, you want to charge it and you want to sync it and you want to store it, then, and you want to prevent the amount of downtime for that device, you need to be able to do all 4 of those processes simultaneously. Well, the LED technology, because of its no heat signature, actually allowed us to do that. So the other aspect of disinfection, and there's really 2 more of disinfection that are key, was not only did you need to do the disinfection properly and thoroughly, but you needed to ensure that you're able to write compliance policies for all of these various assets that are out in the market space. So whether we're looking at iPhones or tablets, as it's depicted here in this image, all of these devices depend upon their workflow. They very well may need different disinfection policies written. So once those policies are written, then we have to ensure that they're being followed and that there's compliance with that policy. So our disinfection side of the electroclave allows those end users, infection control and departments to work together to say, okay, based upon the patient interaction or the workflow of this device, and keeping in mind that at a minimum, the CDC is recommending a 5-to-1, we're going to write these compliance policies, meaning that this device is going to come back to the electroclave every hour and go through a high-level disinfection. This tablet is going to come back every 48 hours, and this tablet's going to come back every 30 minutes. And when any one of these assets do not come back to the electroclave for that high-level disinfection, we're going to take actions. And we do the actions in multiple ways with both end-user notifications as well as managerial notifications and reporting. And as you can see here with the validation on our disinfection side, we have a mobile application that is running on all of our iOS devices in the field. And that puts the information of where the disinfection process is right to the end user that's using that device. So real time, as you can see here on this iPhone, that they know this device at this moment is dirty. They've got to get it back to the electroclave. They've got no more time out in the field. So they can take it back and swap it out for a clean device that's ready to go, or they can take it back and wait for that disinfection cycle to actually be finished if it's not a shared environment and it's a one-to-one application workflow. So that's a little bit about the disinfection of the electroclave. I'm going to skip back and talk a little bit about the charging. So early on, I did say that when managing these devices, you have to really think about how you're going to charge these devices, and also the implications of the various ways that you can charge the device. So one of the ways in which you can charge it, obviously there's multiple enterprise charging stations in the market today, but not all of those applications and solutions are smart charging, meaning that they basically give X amount of voltage and amperage to the device as long as the device is plugged up via USB or whatever connection for that device. Some of your ASCOM devices are proprietary connections and pogo pin connections with Microsoft Surfaces, etc. Either way, dumb charging is when we have a charger that sends the same amount of voltage and amperage at a constant rate. That type of charging is what's detrimental to batteries. That is why when we buy a brand new iPhone or a brand new Samsung, and the first month or so of using that phone, we see phenomenal battery performance. Maybe we're getting a day and a half of use out of that device, and then 6 months later, it seems like at best we're getting half a day. That's because us users, we don't charge the batteries the way in which they should be charged, and improper charging does lead to memory loss of those batteries, which in return leads to a shorter life off the charger. So in the electroclave, we built a smart charger. Inside of the electroclave, if you haven't seen one in person, there's 10 USB ports, as my mouse is indicating here, that run on the inside of the cabinet. This keeps the cabinet device agnostic. So whether it is a Samsung or an Apple device or an ASCOM or a Vocera badge, we are not particular about the connection. So with that USB connection, we allow you to charge whatever device you would like to. And we do it via a smart charger. So we know, based upon battery's life, the size of the battery, and the current temperature of the battery, how much voltage we should be sending at that very moment to the device to make sure that we're not causing any further degradation of the battery memory. So that's what we're doing from a charging aspect. Again, very much different than what's in the field, and that's going to help you keep your downtime of your devices to a minimum. It's going to allow a longer life with a particular user in a given workflow, and it's also going to help you from an asset allocation standpoint, so that 6 months down the road, if 30 devices was the perfect number, you're not having to buy an additional 5 or 6 or 7 devices because devices' batteries aren't allowing that same workflow to be adhered to. Syncing, this term is it's used in various different terminologies. Some people refer to it as re-imaging or syncing or provisioning. But essentially what this is when the mobile devices come back to the electroclave, the key for those devices, if they're in a workflow, like I mentioned earlier, to where a patient's interacting with that device and the device must be wiped or re-imaged, the electroclave will facilitate that. So while it's getting disinfected and cleaned and charged at the same time, without adding an extra second to the process, you can be resyncing, re-imaging that device so that a clean device with no patient history from the previous patient is going to be handed over to the next. And then from a storage standpoint, the electroclave is a secured box. And so we do track who takes what device because there's only one way to get into the electroclave, actually 2 ways now. You can either use the keypad that you see up here at the top, and every user in the facility is given a unique PIN that allows them to get into the box. Or in our most recent version, we have added an NFC reader here on the side, often referred to as tap and go. So you can now access the box as an end user with your employee badge. Maybe the same employee badge that allows you to log into Epic or to access certain records or supplies and supply closets. That same NFC RF badge can be used to open the electroclave. So we keep the doors automatically open once a recognized and authenticated PIN is used, or an employee badge that is set up for that particular electroclave. So at that time, which we read either that PIN or that badge, will open the door. But then the door, once it is shut, that box is locked. And in order for another staff member or end user to come along to gain access to a portable electronic managed by the electroclave, they would have to use the same process. That's how we begin to understand who has what, when, and where. And then once they take that device, where are they going? So skip along, and the way in which we do a lot of this tracking of end users and portable electronics is through UHF RFID. So the electroclave itself has UHF RFID transceiver inside of the box, and that's how we read every mobile device that comes in. That's how I can tell you if a mobile device has been disinfected. That's how we can tell you which personnel put that device in for it to get disinfected. And at the same time, it's the same way we can tell you if that personnel walked up and disrupted a disinfection cycle and took a dirty device and where that dirty device went. So if you're already using RF technology inside of your hospital and you want to be able to get that full visibility of not only the devices that have been cleaned or haven't been cleaned or need to be cleaned, but you also want to know where those devices, whether they were clean or dirty, went and who they interacted with, whom and where and when. Our RF system can integrate to your current RF system, and then you can basically create an entire ecosystem. So if you do not have RF, it's no worries. We're still able to give you all the disinfection compliance and validation. We just wouldn't be able to give you the real-time location of that device. Again, depends upon your setup today and what your setup will look like in the near future. So we mentioned earlier in the presentation that on the back end of the electroclave, not only is it this box that does a lot of fabulous things for the proper disinfection and management of the devices, but there's an entire software that is the brain that connects all of these electroclaves in that ecosystem to give you the ability to write custom workflows. So again, it's instead of a tool, it's a solution. So when we want to write infection control compliance policies by department, maybe in some departments we have particular users that are problematic, we can write infection control compliance policies down at the end user level. So those are fully customizable for the entire health system. Again, user all the way down to the device level, user level, department level. However you want to structure that, the software is what allows that to be managed and to be facilitated. Same as user oversight. So if you're concerned with security about these devices, you're concerned about user usage, who has what device, when and where, and the compliance that goes along with that. The software also helps you create custom workflows to have, basically one-click reporting available to you. So you can make decisions about your mobile device management workflows and if you need to change anything. And also, if once you build these workflows inside the software, if workflows aren't being adhered to the way in which you intended them to, the platform can actually take actions, and we'll show you a little bit of that later. Same applies to device oversight. And usually the next question that pops up about the technology with the electroclave is from a support and maintenance automation. So this is a complex device that's doing a lot of tasks that previously have never been done in healthcare with portable electronics, and it's being done in an automated fashion. So what we did to keep the system usable and manageable so that you're not having to add additional support from maybe biomedical or any other department to take care of this is we fully automated both the support and the maintenance of these assets in the field. And at this point, I'll go ahead and move into some of the functionality inside of the portal. So I won't go through each of these bullets, but just to kind of gives you a breadth exposure to what we can do from an IT standpoint within the software. So everything from active inventory with the RFID tracking to user tracking. We also have door monitoring so that we know if the door on the electroclave was left open, which would cause a security breach. You've got full location assignment and descriptions. Basically, location assignment, the nice thing about the electroclaves from an IT standpoint is most every healthcare institution and most any company organization in the world today typically leverages Microsoft Active Directory. And within Active Directory, you have something called organizational units. You can mirror and mimic organizational units inside of our software so that the electroclaves have location assignments and descriptions that makes sense to your institution, so that we know when certain actions are happening at certain electroclaves, where physically is that within the facility. This looks just what I was speaking to. This looks actually at an organizational unit. So here you can see DaVita, and then within DaVita we have a region. Within a region we have one-to-many facilities, and then within the facility we have one-to-many departments. And then within this Denver dialysis department, we have one-to-many sub-departments. So we've got a location, a nurse's station, and then another location, the receiving area, to where electroclaves will be deployed. So again, this is where you can get as deep as you want with your organizational unit descriptions. Inventory management. This is a quick, a one-click report that very quickly gives you the ability to understand what assets in your organization are where and what status are they. Are they dirty or are they clean? Why do we want to know this? Well, in asset allocation, if we want to truly know what assets we have available anywhere in the institution that can be deployed right now to the field, it's not what devices are just in a box, but it's what devices are in a box that are clean. So the ability to run these reports and filter on that gives you a true determination of allocation within any department, within any area of the organization that the electroclave is deployed. And same thing with active users. One-click report. Very quickly, you can determine which user has which mobile device and where they checked it out from. This is the physical security portion of the electroclave software side. So here you can see that we can actually establish and customize a door alarm setting for you. So this lets you know when the door has been left open or it's ajar. Obviously, if it's left open or ajar, any of those assets that are secure on the inside are subject to be taken out by someone that we do not know. So we want to sound both a physical alarm on the electroclave box itself, which we do, which can only be turned off by shutting the door. And simultaneously, we're going to send notifications to specific managers that need to know about that specific door alarm, who left the door open, especially if it's a repeated offense, and at which location. Moving along here, this is actually showing you within the electroclave portal how we're able to manage notifications for users. So just like I said before, this lets you know which user left the door ajar, what time they did it, and you can do one of two things. You can integrate these notifications into your existing ticket system, or you can manage the workflow of these notifications within our portal to where you can resolve each of these notifications as a manager in the portal, or again, push these via an API over to your ticket system and manage it from where you're already accustomed to managing your IT tickets. Clinical oversight. This is another role inside of the portal. So the first role we looked at is the IT role. This is what we refer to as the infection control role. This is where we write disinfection policies, again, from electroclave all the way down to the user if we want to get that myopic. It's also where we look at, from clinical reporting, what is our disinfection compliance right at this moment? How do we validate that our disinfection is actually taking place? And then we can generate any logs real time or for a specific period. So maybe we're underneath a Joint Commission audit and they want to know what this device is and how it keeps up with the cleaning and disinfection of your portable electronics. Now, instead of having them roll around and interview each of your staff members within departments individually, you can generate a compliance and validation report with one click, hand it over to them, and they can see the life and the disinfection life of any device within any department at any given time, again, real time or for a specific period. This is what a disinfection policy page looks like. So here in DaVita, you can see that we've got 4 mobile devices within a specific department selected. We know what the RFID tag of this device is. We know what its serial number is. And the policy limit, this is where we define how much time in between each disinfection can occur. So you can see with this particular iPad that 1,440 minutes is roughly high-level disinfection once a day. So with this iPad, they're making sure that they're hitting that 5-to-1 CDC metric. Where some of these iPads, maybe because of the patient interaction with a typical dialysis treatment, that these devices are being disinfected every 30 minutes. And this is the one-click report from a user audit standpoint when it comes to disinfection to determine which users have which devices and what did they do when they checked the device out. Did they grab a clean device or did they grab a dirty device? And is that device that they currently have right now in compliance? So that's a very important metric to look at in disinfection. It's always not only is the device in compliance, but it's also understanding the behavior of our users and their workflows. Are they always taking clean devices? Or on certain days or certain periods of time, do we always see that they're taking a dirty device? And maybe that, presents us a way to approach them to say, why is it that you're having to take a dirty device always within this span of time? So this gives us the data to make decisions that otherwise, again, we would have no idea about. And then last but not least, on the support side, when I talked about the full automation of the support and the maintenance of the unit, this is all the functionality that the software allows us to do. So without going through each bullet point, in essence, every single function of the electroclave can be monitored remotely. And depending upon how the hospital wants to engage with maintenance, we allow you to either become a user in the portal so that you have the same visibility to the maintenance of the unit, or you can turn that maintenance over to a third party, and then the third party knows what's going on with your unit or units within your institution 24/7, 365. We'll know something's wrong before your end users report an issue to create a ticket to call us to say the box is not working. We'll know before you do. So the portal is essential and pivotal to understanding the heartbeat of the device and what's going on and what actions need to be taken at any given time. This is the typical network topography of the electroclave in the healthcare institutions today. So typically they are connected all via a Cat5 or 6 cable directly to one of your switches within a department. And then they're communicating here through the cloud to our software. Again, this is the brain for all of the electroclaves. And then if you choose to use a third-party support provider, this is where the cloud communicates to their ticket system to let them know what's going on with all these boxes in the field so they can take actions when they need to. And last but not least, again, if you haven't had the ability to see one of these electroclaves in person, this is the physical dimensions of the electroclave. It's roughly a cube. So a lot of people say we don't have any room in the hospital. We're already, basically out of space for deployment of any additional technologies or assets. And I can tell you now across multiple healthcare systems in the last year, I don't think we've found a department yet that cannot fit one, if not 2 or 3 electroclaves, even when that department in the initial assessment said we've got no room. Because the way these are designed, they can be tabletop mounted or wall mounted. So we've got electroclaves everywhere from supply closets, maybe in the room where your printers or your copy fax machines are, to break rooms, to nurses' desktops. I even have electroclaves in operating rooms in the central core to where they do all the preparation of instruments for given procedures that are scheduled for the day. So there's really not a place they cannot be implemented and deployed within the system. The only thing we need is, again, the data drop, and that can be Wi-Fi or Ethernet. We prefer Ethernet. And, you're looking at a 16 by 15 by 13 inch cube. So that is the electroclave, both high level, the research behind why we developed it, and its current status as it's deployed throughout multiple institutions today to truly, again, help manage mobile devices when it comes to their full life. So not only just disinfection and cleaning, but also full user and device oversight and management. So at this time, I'll go ahead and I do want to say thank you for joining us today to learn a little bit about the electroclave. Any questions that you have in regards to the technology, feel free to reach out to anyone at Derive, and they would be able to assist you or connect you with us at SealShield for maybe a more in-depth presentation instead of an overview, or if you'd like to understand a little bit more about some of the research that's been done around portable electronics, and even some of our current case studies at our go live sites throughout the US. We'd be glad to provide that and help you understand more about what we're doing here in the US, as well as Australia and New Zealand with the electroclave. So with that, I'll go ahead and close it out today. Thank you for joining, and look forward to speaking to you in the future. Bye-bye.